It's another tech day. I dusted off my old mechanical key. It's a basic one. I think it's a mid-range white shark, which I paid around back then maybe 40 euros. Nowadays it's probably a lot cheaper, but I really love the sound of it. Listen. I hope the microphone could catch that. But why I like it, because it gives me a nice glow. It gives me a hackerish vibe. But what I want to do today, let's warm up. I need some warm up, and this is the best way. So I need to guess this game. And there's some beaten at right here. There are some brick walls, and let's look at this. Look at this. There is some jitter here. There are some rough edges around here. Most probably because they couldn't smooth them properly when they built this game, and I assume this was created somewhere around 2010 till 2015 or 16, maybe a year earlier or later. So we have these jagged edges. They are called aliasing, and modern games have anti-aliasing techniques to hide them. So this is one of the clues, but I have no idea. This is gonna be a stupid guess. Of course, something not rated. There's no way this is older. And this is definitely a lot older than I initially thought. What the hell is this? It definitely not this, but I want to check whether we guess the correct series. No? PC. What is this MMO? Alright, so I have never played any MMO in my life. Like, never. So for me, this could be, as long as I hear it, this could be World Warcraft. So of course, said 2005. So this is this. So for me, this could either be RuneScape or Guild Wars, and I think, let me just see, Guild Wars. What the hell? And I know that RuneScape came out maybe in 99. So these are the only three MMO. Actually, I know, what's the name? City of Heroes is another one, but I think this is Guild Wars. No, I have no idea what this is. I have no idea what this is. I will just skip it. What the hell is this? Oh no. Oh no, could it be? Damn. Okay. Alright. So Silk Road. Even though I never played it, I think I remember the UI. Let's do another one. Another one. I have no idea what this even could be. Dark, there are some dead trees and there's snow, but I can't reference this. I can't connect this to anything I know. Okay. Let's try to see if I played a game or if I saw someone playing a game on YouTube that reminds me of the nightmares I had as a child. No, I have no idea. I need to skip this one. I have no clue what this could be. Too old for Metacritic. Oh god. This would be a stupid guess. Wait. Called Contra? Contra. Wait. Contra Rogue Corps. Of course, it's Sega Saturn. So this is it one of the Castlevania games? No, it's not. Platform rhythm minigame. Okay, boys. We bombed once again. We blew another chance. I have no idea what this could be, but 1996 platform rhythm minigame on Sega Saturn. Mr. Bones. Okay, this one is really this one really caught me off guard. I have never heard about this game. I have never seen it. Especially when it said rhythm minigame inside us. Okay, okay, brother. We are not guessing this one. We have we are not doing very well. We guessed one after after 5 guesses. We need to redeem ourselves. Let's see. Man, what the hell is this? I know that someone who has played whatever this is, it's Kingdom Hearts or Final Fantasy, would scream in the comments saying, "You idiot! This is the exact texture of water in one of these games." But I'm not built of that cloth, brother. For my first guess, this is really old. This is like 2000s, around 2000s. I don't know. Deus Ex. Of course, not Deus Ex. Ooh, but the Metacritic score is quite high. Is it? Is it Throne? I don't think it's Throne. Because Throne was a good game, but I don't think it was that good. Of course not. N64. What? What could this be? I need to skip it. Ah, wait, 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 wait. Um, Star Fox? I just remember it must be Star Fox. Star Fox. Okay, we are in the right franchise. That's a good. How many of these? So it's 64. The console, it should be Star Fox 64. I remember seeing this once in one of these. You know these top 10 videos, essays, top 10 most underrated games, or top 10 games in which characters need to face a ridiculous moral dilemma or something like this. And I remember seeing Star Fox multiple times. Actually, it was quite a hit back then. I never played it, to be honest. Okay, some soft shadows. A good modeled chair, some shoes. This must be a newer game, but from this, I don't get a lot of information. I don't get a lot of information. I need to skip. 73. And the second picture is as confusing as the first one. If not more. No. Snow. What games had snow? I don't know, some of those Call of Duties, but I remember guessing Call of Duty like maybe 20 games from this one. I wouldn't think they would put another Call of Duty. I remember in Modern Warfare 2 you had a winter section, but this PS5, PC, yeah, this is something really modern. Xbox Series and Switch. Okay, let's not make a stupid guess. PS5, PC, Xbox Series, and Switch. This is something really, really new. I know what this is. I know what this is. I know what this is. Let me just take another one. Adventure. No, I don't know what this is now. What? Adventure. 2024. Oh god, I know what this is. I don't know the name. And I don't think I'm gonna guess the name. Is the same guy or the same team that built, or is it Life is Strange? And this must be the game from the same developers. I'm gonna think about it. And I'm gonna oh no. What could this be? Because I remember I never played Life is Strange either, but I remember thinking that Life is Strange had a bigger score than 73. Unless this is a sequel of it? Venture. tchdy. Wait, it's a sequel. Life is Strange. Oh yeah, they have a lot of these here. Could it be Life is Strange 2? Ah! I didn't even know that they had Life is Strange 2. Life is Strange. Graphic adventure game 2018. And what was this one called? Double Exposure. Okay. I won't consider I won't consider guessing this, even though if I had better clues, maybe at this point I would make a connection between what I'm seeing on the screen and Life is Strange, and I would maybe pick Double Exposure, even though I never played, even though I never heard of it. Why? Why are you torturing me? Why can't I get one good, only one good game so I can start working? Why are you torturing me? Why? The 2D platformer, it might be anything from Donkey Kong, some Super Mario episodic feature, or anything else. Any platform, anything. I have no idea. I need to skip. Original score tool for Metacritic. Okay, it's gonna be stupid. Rayman? No. Arcade. This is gonna be even more dumber. No, this is not Donkey Kong. Hercules? Why? Fighting. Fighting. Alright. What do I know? I know about Tekken. I know about Mortal Kombat. I know about Soul Calibur. I know about Street Fighter. What else? What else? Super Smash Bros. No? There's no way. Mortal Kombat. 3. It makes sense. It makes it. I'm an idiot. And which one is it? Which one is it? The OG one? There's no way. Is it? Capcom in 1997. It's definitely not anything after 5. Anything after 4, I don't think it is. So it's either 2 or 3, and I see 3 being the one that is recommended first, even though I have 2 guesses. So no, I don't have 2 guesses. I have 1 guess. Street Fighter 3. Street Fighter 3 New Generation, Street Fighter 3 Second Impact, or Street Fighter 3 Third Strike. How many more do I have? 2. Alright, let's do both of these and then let's start working, boys. This is something I've seen. This is something I've definitely seen. Something new, something contemporary, something modern, high scale. Oh, c'est total bake. It's altering. Am I just an idiot? Am I just an idiot? Is it Demon Souls? Action role-playing game. I see a knife. I see a blade here. A red blade. And it's a 78 score. Why have I guessed Elden Ring and Demon Souls? Those are like some of the best games ever made. 78%. So it's not God of War. Yeah, it's a stupid Souls-like. Wait, I know what this is. It's something first. No, it's Conan. First Conan. First Berserker Kazan. I also saw this on a video. I think about it. I haven't played a lot of these games that I'm guessing. Dirt Road. Does the texture reminisce anything of a childhood memory? Playing on my PC or a rented PlayStation? No. Keep it. 74 Metacritic score. Some boxes. You could beat me up. I wouldn't know what this is. You could torture me with burning my fingernails with hot irons. I would know what this is. PS4, PC, Xbox One. It's a hook. Abortion hook. Okay. Horror survival. '74 horror survival. I know this one as well. It's a stupid parkour game. Oh, Not dead island. Dead or no? Dead island. Not dead island. It's dead. Something dead. Dead. Dead light. Dead light. Dying light. Which one is it? There's only one. Dying light. I'm on a roll, my brother. Oh, okay, I guess this one. Let's do one more. 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 Oh, I missed all of these here. 1280. Okay. This one. We need a good, clean guess. Good, clean guess. So, a bus chair or a plane chair with some text saying CA, me as a Hellraiser Sherlock Holmes type of detective, I deduct that this doesn't make any sense. I have no idea what this is. California? No. Skip. Let me do a guess. Let me do a guess. A stupid guess. Half-Life. 91%. 91%. So I play this. Definitely. Always play these highly rated games. What is 91%? Maybe Uncharted. It has an Uncharted vibe. Not Uncharted. PS1. PS1. Wow, this almost fooled me. PS1. PS1. What was a great PS1 game? No idea if Resident Evil even came on PS1, but yeah, it is. So it's the second one, most probably. Okay, this is a dead giveaway, and I assume, yeah, this is Leon doing his best to survive. But the first two, this almost fooled me into thinking it's something new. And this one as well. Oh, my idiot! This is the police station. I'm an idiot. This is the police station. Is it? Oh no. Okay. No. I'm gonna stop here. We're gonna stop here. Let's continue. Alright, girls and boys, let's do something productive here. Let's do something down. So we have an exercise here. And the exercise says a function f is defined by the rule that says, okay, I have a really short cable. I bought one and it came, and I thought it would be longer, but it's like 10 centimeters. So now I need to move it around to find the best placement for it on my tablet. Oh. It's not good. All right, maybe here. Maybe here. So it says a function f is defined by the rule that says something Write the procedure that computes f by means of a recursive process. Write a procedure that computes f by means of an iterative process. Okay. Where are we? We are here. And it's here. So we have a function f, and the rule says f of n is equal to n if n is less than 3, all right? And otherwise, if n is greater than 3, we would have f of n minus 1 plus 2f n minus 2 plus 3f n minus 3 if n is greater or equal than 3. All right. So we need to write a procedure that computes f by means of a recursive process. Write a procedure that computes f by means of an iterative process. All right. So sooner or later I would need to set up a Lisp interpreter on my machine. Sooner or later I would need this. So let me just Google how to do this. Let me just ask ChatGPT how to do this. So there are two options. You want a scheme interpreter, a kind of Lisp to follow this book, so not any random Lisp. The easy and modern setup is to have a racket plus the language from the book, or to have a MIT/GNU scheme, which is the one closest to the original course. And no, let's not do it now. Let's try to solve this example, this exercise by hand. All right, so this is the formula. If the number is 0, 1, 2, we are returning this number. Otherwise, we are computing. So if we have 3, we are computing a sum of the previous numbers. So 2 plus 2 times f of 3 minus 1, blah, blah, blah. All right, so we are computing a weighted sum in any other case, in any other scenario. And if I compute a couple of values right now by hand, I will have f of 0 is 0, f of 1 is 1, f of 2 is 2, f of 3. Yes, now we are hitting it. We are doing f of 3 minus 1. This is 2, this is 1, this is 0. So I will do 2. Keep in mind, this is not only the value 2. We are lucky. Okay, wait. What was I saying here? Yeah. So let's do a couple of these exercises. F of 3 is maybe it will be better just to say, so it's f of n minus 1. It's f of 3 minus 1. As I said, we are lucky that the value is 2. Maybe in another function, the f of 2 would be 2.5 and we couldn't just plug it in here. But in this case, we are lucky that the value is 2. So I'm just gonna write here 2 directly, the value. plus I have 2 times f of n minus 2. It's 2 times f of 3 minus 2, which is 1, plus 3 times 3 minus 3. It's the value of f of 0. It's 0. I'm just jumping ahead of some steps in order to do this so quickly. So it's 2 plus 3. So 2 plus 2 times 1 plus 3.0, and it's 4. And let's do another one. It's gonna be f of 4, and it's gonna be f of 4 minus 1. I'm gonna write everything here. F 3, 2 times f of 4 minus 2 plus 3 times f of 4 minus 3. Right. 4 minus 1 is 3. The value of 3 is 4. I'm gonna write here 4 plus 2 times 4 minus 2. It's 2. The value of 2 is 2. It's 4 plus 3 times f of 4 minus 3. It's f of 1. It's 1. This will be 9. So, okay, so what this formula actually describes is all the square values that we have for each number. So the next one, for f of 5, I would assume the next one would be 16. Oh, I made a mistake. I'm an idiot. Not 9. F of 4 minus 3, it's 1 times it's 3. It should be 11. So it's not, they're not square values. Also, it wouldn't be square value because I have a 2 here. So let's do f of 5. The last. Oh, f5. So f of 5 minus 1. F of 4. And the f of 4 is 11. So I have 11 here. Plus, what else do I have? What else do I have? It's 5 minus 2, so it's 3. So I'm multiplying it 2 by the value of f2 by the value of f of 3. F of 3 is 4. 2 multiplied by f of 3 is 8. We have another one. So it's f5 minus 3. It's f of 2, and I'm multiplying it by 3. F of 2 is 2, 6. It's 25. But this is a square. This is not a square. Interesting. Interesting. By the way, I really love this marker because it removes itself. But if I keep, now I'm keeping my S Pen at the end of it, it stays. So not only I can show things, but I can keep it for a longer period of time. Cool. Actually, let me just move it. Move it. All right, too bad. It would be cool if I could. I won't complain. All right, let's do and let's create the recursive. So what we need to do is just create and translate actually what we have here. I'm confused because I remember the laser pointer being here, but we just need to convert this into code. So define f of n. We just need to translate the math into the code. The base case says if, wait, I used, I think, condition here, but I'm gonna use it because I'm better well versed with this. But I think it should be more or less the same thing. So if n less than 3, return n. Else, they have else here. They do else, else. So I'm summing. I have so much trouble trying to understand the syntax of Lisp. It's almost infuriating how ridiculous it is. F, but it's mathematical. So minus n1. So I'm summing this with another one. 2 times no. It should be wait. It should be like this. Multiplication 2, and then I have f. This is so bad to read. I don't know if my syntax is correct. I just want to have the correct process in my head. F minus n2. I assume it's like this. I need to the plus here. So this one closes this one closes this one. All right, wait, let me just do, and this one closes this one, and then I have 3f minus and 3, 1, 2, 3. This closes this, and the big one that closes this plus here. All right, but that should be correct. Again, I think I missed a couple of parentheses here and there, but I believe that the underlying logic should be all right. Yeah, I definitely missed. For example, this connects with this connects with this connects with this connects with the plus. I need one for the else, and I need one for the if that's open there. So I need 2 more of these guys. All right, okay. Now, this is correct. But if you remember from the book, from the theoretical part, basically this is really bad because it creates a tree recursive process in which we multiply a lot of the same work. For example, here if we have 5, this could be 5 as well. So all of these branches down there are just copied without any need. Because, yeah, fn calls fn minus 1, fn minus 2, fn minus 3, etc., etc. I'm just looking at options here. What is the dot? Oh, the dot is only showing it. I don't want this, but I love the laser pointer. This one has an edge to it. Okay, let's leave this one. All right, so this is clear. That is really efficient. In order to compute f of n, I only need, as the formula requires, f of n minus 1, f of n minus 2, and f of n 3. So we don't need recursion. We need the last three values. And we need to store them somewhere. So one of these values will be stored in A, the other one will be stored in B, and the last one will be stored C. So our initial, because we already have these values here, our three initial values will be 0, 1, and 2. And then we need an iterative formula, and then we need to shift. So let's do this again. But this case, the if, same thing, n is less than 3, I'm returning n. But otherwise, I need to create a method f iterative, in which I will call the three values 2, 1, and 0 for n. I forgot the define. Let's say it's here. We don't care. Now we need to define the f iterative version. It's ABC and count. Okay, so this is the iterative function. This is the iterative function here. So we also need a stopping mechanism. So if count is equal to 2, we are returning the first value, so we're gonna return A. Otherwise, if not, let's call this guy again. With what values? So otherwise we have this, and I need to sum A, I need to sum 2B, and I need to sum BC. So I'm calling this. But what are the values that I'm calling? A, B, and the count is reduced by 1. if I do a real example with the value of f5, what are we getting here? If I call f of n with 5, I would get here f iterative of 2105. And we are going to fill these values into the method here. So 5 goes down because the first iteration says here that we have what? Where is it? 2 plus 2 plus 0. It's 4. So this will be the new A value. This will be the B value, and this will be the C value. So the next iteration will be, I'm getting here 4. This is the new value, 2 and 1. And I'm, of course, reducing the count. It's going to be 4. Let's do another one. So I know that I'm returning here 4 and 2. But this one will be 4 plus 3, it's 11. And this is 3. Let's do another one. I know that I'm returning 11, and I know that I'm returning 4 here. And this one will be, if I'm not mistaken, 25. And we are here. The count is 2, so we return 25. Nice. Ooh. All right, let's do the next one. The next one is saying the following. Exercise 1.12. So it's the exercise 1.12 from the book, and it says the following pattern of numbers is called Pascal's triangle. Okay, so a Pascal's triangle, and it looks something like this. So we have a 1 at the top, then we have a 1 here, 1 here, then we should have 3 elements in the next row, 1, 2, 1. The next one should be 1, so 1 plus 2, it should be 3, 1 plus 2 should be 3, a 1 should be here, another one here, and this is 4. If we sum 3 and 3, that's 6. If we sum 3 and 1, that's 4, and we add a new one here, and so on and so forth. So we have a triangle, grows, and the numbers at the edge of the triangle are all 1. And each number inside the triangle is the sum of the two numbers above it. Write a procedure that computes elements of Pascal's triangle by means of a recursive process. Okay, let's do this. So mathematically, how does the Pascal's triangle look like? This is the formula based on the rows and columns. And these edges here are always 1. So it's 1 for what? It's 1 if column is equal to 0, or the column is equal to the row. So this is 0, this is the 0th column, or this is the first column, no, sorry, this is the zeroth row. This is the first row. This is the zeroth column, and this is the first column. This is the second column. Sorry, second row, but this is the zeroth column. First, second. Oh, so it makes sense. So it's always either the first number in the column, but we order it to start from 0, or the last one. So this was the simpler part. How about all the other elements? How about this element? How about this element right here, for example? It should be a sum of the two elements above it. So I should have this element is the element. Wait. So if this is an element, that's on row and column, I want it to be a sum of the row above, so -1, and column to the left of it and to the right of it. So it's gonna be, wait, I have it. So it's gonna be C -1. No, it's gonna be R -1, C -1 plus R -1, C plus 1, or C. So it's not C plus 1. Why is it not C plus 1? Otherwise, so why is it not C plus 1? This is 0, this is 1, if this is 2, and if this is 0, this is 1. So this element is 0, 1. Zero, 1, 2. Ah, no, so it's I'm hungry, I need to eat something. I'm hungry and I need to eat something. Yeah, the column starts at 0, but the problem is this could be 0, and if I find another one, that could be 0 as well. Oh, so maybe it is. So if this is 0, 0, and if this is 0, the first row, 1, 0, 1, 1, 2, 0, 2, 1, 2, 2, 0, 2, 1. This is the second row and the first element. So it should sum up the first row and the 0th element and the first row and the first element. Yeah, makes sense. Oh, took more time for me to understand it, but I think we are good here. So we just need to write the recursive procedure here. Let's do it. Define. And it's gonna be Pascal. and I'm looking for the row and the column. So I have a condition saying that if the column is zero, or, but the or needs to be the or, because of the way this flavor is written, the or needs to be here, or equals columns and rows return 1. And what are we otherwise returning? In the else block, we're returning this mathematical formula. The only thing I need is to convert it into code. And how do I do that? Plus, I'm calling it recursively again. Gonna be Pascal row minus 1. Gonna be Pascal column. And I'm never getting used to this syntax. Column minus 1. So this is the first part of the summation. The second one is Pascal row minus 1 and column. That's it. I have a couple of these parentheses to close off. I hope 4 is enough. All right. Now, I could look for a concrete example. For example, let's say I'm looking for this is not how you write Pascal. Pascal 4 and 2. So if I do step-by-step expansion, what will I have? I will have Pascal 3.1 plus Pascal 3.2, and then I'm expanding both of them. 3.1 will be Pascal 2.0 plus Pascal 2.1, and Pascal 3.2 will be Pascal 2.1 plus Pascal 2.2. So this is a base case. This returns 1. This returns 1 as well. If I keep on going, I would get what? So the fourth row, 3, 4, and the second element, 0, 1, 2. I should get 6, and I think I will get 6, but wait. Okay, let's expand it. This is 1 and 1, so this is already 2. I have 2 and 1. I have 2 and 1 twice, so I'll just need to do one of them and it's gonna work. So this is gonna be Pascal 1, 0 plus Pascal 1, 1. 1, 0 row columns, so if the column is 0, this is 1, 1, and if, because I have 2 of them, it's gonna be 1. This is gonna be repeated twice. I'm gonna have 1, 2, 3, 4, and this one again, 5, 6. Okay. Okay. All right. should we do another one? There's one more exercise, which is, it seems quite complex. Maybe let's do another one, this one, and we can end today's episode and do another one. Okay, so what are we having here? It is saying, prove that Fibonacci of n, the Fibonacci of n is the closest integer to what even is this? This is phi, or the Golden ratio, is the closest integer to phi n over the square root of 5, where phi is equal to 1 plus square root of 5 over 2. And so we just need to prove that the Fibonacci of n is the closest integer to this. Blah, 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 blah. There's a hint. There's a hint with psi. I think this is called psi or psi. So it says there's a hint. Let c be 1 minus square root of 5 over 2. Use induction and the definition of the Fibonacci numbers to prove this. I have no idea what any of this is, to be honest. So I'm gonna ask my friend here, the tchdy. So this is phi, and what's the value of this? 1 plus square root of 5 over 2. Okay, let me just pretend like I'm calculating this. It's close to 1.618. And this value, so this is phi and this is psi. And psi is minus 0.618. Wait, what do I even need to do? Prove that the Fibonacci of n is the closest integer to this value right here, where p, not p is this. Okay. It says here some simple intuition first. Okay. Notice that the absolute value of c, or whatever it's called, is less than 1. Which means what? C of n shrinks towards 0 as n grows. All right, so we can actually prove it. I'm gonna open my calculator. Can you see it? Is it on screen? It should be. It is on screen. Okay, so this is the value squared. No, I don't want any angles. I want. All right, so it's minus 318. All right, so if I give it, if I raise it to the power of 3, where's the raising functionality here? Minus 208. If I raise it to the power of 4, let me copy it. Power of 6. No, power of 6. Power of 12. Power of 25. Power of 35. Power of 125. So it most probably can calculate it, but let's say 44. All right. So what is happening here is that as we increase n, psi on n is diverging towards 0. All right, simple intuition. I'm good at it. I'm good at it. I'm good at it. Okay. Now, there is something that is called Binet's formula, and it says that the Fibonacci of n is Pn over square root of 5. What? How did we came to this guy now? The trident over the square root of 5. So it's saying that this term, because it's growing, it's becoming tinier and tinier. So the Fibonacci of n is close to this singular value. All right, so this is like a proposition. We need to prove it now. And then it says if the error is less than 1/2, then the nearest integer must be our value, Fibonacci of n. So we need to prove Binet. What an unfortunate name. No, sorry, it's not Binet, it's Binet's formula by induction. And prove that the error bound is less than 1/2. How? So we have somewhere above the Fibonacci formula. I know I have written it somewhere. I know it must be here. Where the hell are you? Alright, doesn't matter. Basically it's saying the Fibonacci of 0 is 0, the Fibonacci of 1 is 1, and the Fibonacci of n is the Fibonacci of n minus 1 plus Fibonacci of n minus 2 for every n that's greater or equal than 2. As a reference, 0, 0, 1, 1, and Fibonacci n minus 1 plus n minus 2 for n greater or equal than 2. Okay, now here it says there are some key facts about our two symbols, about P and C, or the trident. Both satisfy whatever this is. How? How are they satisfying? Why are you just implied shit that I don't know, that I'm too stupid to understand? What, how do you mean it's satisfied? This if you put here 5 plus 1 is not equal to 5 squared. How is this satisfying this? Ah, okay, okay. Me being stupid again. Basically, satisfies this thing right here. So 1.1618 plus 1 would be the same as this guy squared, which it is. All right. That's the thing I didn't know, for example. That's because I should have studied math a bit more, to be honest. But because both of these guys satisfy this, I'm gonna have b squared is 3 plus 1, and c is c plus 1. Which means what? Which means what? Ah, it means this. All right, look at this, boys. So let's say this is proven, and now look at the calculator here. I go here, and if I say this is, go to hell, this is 4, 6, 8, 5, 3. 3 on the fourth is 6.853. And then if I go back and here I put 3, it's 4.235 plus I put 2 here, 2.6, 2.617. And if I do now, I could have just done this. I copy. Why can't I copy? Why can't I copy this? 6182. This should be 6.853. Ah, I feel like I'm discovering some hidden universe secrets, and I'm just doing the most basics of that. Which means that for every n that is greater or equal to 2, we will have p of n is p of n minus 1 plus p of n minus 2, and c of n is c of n minus 1 plus c of n minus 2. So this is some basic intuition, and we want to prove the following postulate: f of n is p of n minus this of n over square root 5. All right, so we are claiming this, we are claiming this, we are claiming this, and we want to do it by induction. And if I remember correctly, by induction we send some base cases, and our first base case for n equals 0, f of 0 should be any number that is, if I'm not mistaken, any number that is squared to 0 is 1. 1, square root of 5 is not important in this case, and it's 0. F of 1 is b minus c over square root of 5. But because we know that, where are you, brother? That here, b is 1 plus square root of 5. This is 1 minus square root of 5. Over 2. So this should be 1 plus square root of 5 minus 1 minus square root of 5 square root of 5. This is gonna be a plus, this is gonna be 2, it's gonna be 2 square root of 5, so over 2 is gonna be only a square root of 5, and because we also have a square root of 5 back down, it's 1. It's 1. But now we need, because we think that the formula holds, we need to find the Fibonacci of n. And the Fibonacci of n will be b n minus 1 Oh, I completely forgot to turn this off. Okay, so we are replacing this instead of here. b minus 1 minus c and minus 1 over the square root 5 plus same thing, only it's gonna be minus 2 square root of 5. So what do I have here? I'm gonna have a square root of 5 down here, and above I'm gonna have, because I'm gonna group the same values, I'm gonna have 3 minus 1 plus 3 minus 2 minus c minus 1 plus c and minus 2 . And if this is c of n and this is phi of n, and I have it here somewhere. Yeah, I have it here. We actually have proven that these values are actually okay. It's gonna be phi of n plus c of n over square root of 5, and the formula holds for n. That's actually only the half of it. The second half is showing that the Fibonacci of n is the closest integer to phi of n over the square root of 5. So let's go down. Oh shit, I need to run again. Let's continue this some other time. Thank you. Bye.